All right, so we're going to talk about delta Y transformer bank connections again. And if you remember the last video, we were talking about it, and I said that if we have it referencing the X1s, we would be 330 degrees of displacement, 30 degrees back from A phase. But believe it or not, there is two methods to do this. And in the old days, they called it the 11 o'clock method or the 1 o'clock method. In our case, because we start A phase 0 degrees at 8 o'clock, the last method I showed you was the 7 o'clock method. This way is going to be the 9 o'clock method. So you see I have that written up here. Delta Y connections, 9 o'clock method. Now, generally speaking, if we're looking at this vector and I want to use the X1s, I'm going to reference my A phase starting at the tail of this vector. And I would take it and I would slide it over, and it would slide right here, which would end up being A phase, X1, and that would be at 330 degrees, or 30 degrees from 0. Now, there's another way we can do this. And if you remember the last video, I said you could never get this A phase and an A phase on a Y delta to phase together. Because a Y delta, your A phase would be up here. On a delta Y, your A phase is down here. And that is true A phase. Because if I look at my primary and I go ahead and I hook this up, H1, H2, H2 of transformer 1 ties to the H1 of transformer 2. H2 of transformer 2 ties to the H1 of transformer 3. And finally, the H2 of transformer 3 ties to the H1 of transformer 1. And we know this to be A phase. And if we go back up here where these two tie, we know that to be B phase. And here we know this to be C phase. Now, make no mistake, when I look at the coil of this transformer in here, A phase fires first, then B phase. So even though A phase is hitting H2, at the same time it's hitting H1, B phase fires second, so my current is going to flow this way. And back in that loop, so it goes this direction. But the interesting thing that I've learned while looking at this is if you reference the X3s, which would be 210 degrees of displacement, and I just go put an A phase here, and then 120 degrees from there is here at 150, B phase here, and then C phase here. So A, B, and C. Let me just erase this 30 degree mark and put the A phase so you can see it more clearly. Now, if I go ahead and draw these lines in, and I call this, so if we look at it, transformer 1 would be up here, T1, but you notice that says B phase and not A phase. But what we're doing is we're referencing the B phase instead. When you reference the B phase, the head of an arrow, that's technically 210 degrees. And that's the rules of vectoring. So whenever we take our delta and slide it over, ordinarily on any other transformer, we would reference this phase. But on this, if we reference the B phase, and if we reference the C phase for T2, and if we reference the A phase for T3, so T3 would be here, T2 would be here, and now let's look at that. T1 is saying B phase X3, and these are the X2s. And of course this gets grounded. So if we go here and T1 says B phase, T2 says C phase, and T3 says A phase. Now we look here, A and that's B, B and that's C, C and that's A. That looks wacky, but that's still clockwise rotation. And believe it or not, C phase, which we're calling A phase here, will phase with a Y delta connection if the phase-to-phase voltages are the same. And that's why the old timers used to call it, there's either the 11 o'clock method or the 1 o'clock method, and that's when they started A phase up here at 0 degrees. In our case, since we started 8 o'clock, we're calling this the 9 o'clock method. It's a perfectly viable way. In fact, some of the old underground pad-mounted transformers that you look at would have the vector drawn just like this. It used to be a standard to draw the vector like that. It's not so much a standard anymore. We've kind of morphed into a couple different ways to draw the vectors. This is a viable way, and if you teach it like that, by all means, keep teaching it like that.